Today's lesson is 9.2, End Behavior. If you take a look at any polynomial's graph, here is the example of a quadratic, because it's a parabola. You can identify the zeros, roots, solutions, and x-intercepts as the point where the graph, the function, crosses the x-axis. So there would be my zeros, which are also called my roots, my solutions, my x-intercepts. I can use any of those words interchangeably. The y-intercept is the point where the function crosses the y-axis. So where is my graph touching the y-axis? And what we're going to talk about today is the end behavior. What's happening with the behavior of my graph of f of x as x approaches positive or negative infinity? Positive infinity is, of course, over here, and negative infinity is over here. So what's happening? This graph is going up and up. And then what happens in the middle depends on the degree. So let's go ahead and take a look at what happens. But every time that we talk about end behavior, we have to make sure that we are in standard form. This means that my degrees must be in order and they must be in descending numerical order. That means the largest one comes first, and then we just count backwards. So what I need to be certain of, the one term that I have to look at is this one right here. This is called my leading term. So I'm always going to be looking at my leading term. And I have to have it in standard form for it to be a leading term. All right, so what happens when my leading term has a leading coefficient that is positive and its highest degree is negative? Let's go ahead and look at our leading term. This is our leading term right here because notice it matches this right here in standard form. What they're talking about here is that your leading coefficient, this part right here, is a positive number. Okay, positive 2, positive 3, positive half. It doesn't matter what the number is, it just has to not have a negative sign. And when the degree, which is right here, when its highest degree is even, when this highest degree is even, 2, 4, 6, 8, who do we appreciate? And so on and so on. The leading coefficient is going to tell me what's happening on the right side of my graph, and the highest degree will tell me what is happening on the left side of my graph. So here is my example. Here's my example of my polynomial. I'm not going to go to Desmos. The whole purpose of this is to not put it in a calculator. What does the graph look like without actually graphing it? That's the whole purpose of this. So you have to make sure that you are in standard form. So find the highest, the largest exponent, and then make sure that it's in order descending. So 4, count backwards, 3, 2, 1, none. It's in order. This is standard form. Here is my leading coefficient. There's nothing there, so it's 1. And guess what? It's positive because I don't see the minus sign. And then this is the degree, because that whole term right there, just this part, is this guy right here. All right, so what's going to happen? Well, the right side of my graph is going to rise. It rises. It's going to go up. It's going to look something like this. Okay? This is because my leading coefficient is positive. And I'm going to write that down here. So here's what's happening. As my x quantity is going towards positive infinity, my y values are also going towards positive infinity. That's what the rise means. Well, what does the left side do? Well, the left side is based off of my highest exponent. This is the even or the odd. When it is even, it does the same as the right side. Okay, so it's going to do the same as the right side. Since the right side rises, so does the left. Okay, but it's not rising because it's even, it's rising because the right side is rising. Okay, so you always want to do the right side first because the right side is going to dictate what the left side is doing. This is because my highest degree is even. Okay, what's happening here is as x is approaching negative infinity, my y value is approaching positive infinity. All right, what's happening in my graph in between my two ends just depends on what my degrees are, okay? So there could be a lot of twists and turns, and we're going to talk about those in the next lesson. But right here, I have an idea of what this graph should look like before I've even graphed it. Now what I'm going to do is I am going to go ahead and go into Desmos, and I'm going to put this equation into Desmos, and I'm going to show you the graph. Let me grab my pen. All right, so I'm going to put x to the fourth power plus 3x squared minus 5x minus 2. And there's my graph. I'm going to go ahead and zoom in on it a little bit. Looks very much just like a parabola, huh? I could go in and grab, doesn't look right. Hold on a second. Nope, it's good. So I'm going to go ahead and grab the table. There's some points that we could plot. I'm going to go ahead and plot 0, -2. I could do -1, or sorry, I could do 1, -3. I don't think I could do the 1, 7. I don't think I have enough. 1, 2, 3. Yeah, I don't have enough. So it looks something like this. And I think if we zoomed in enough, there would be a little bit of another little bump in there, but I just can't zoom in enough. All right, but notice what I want you to notice in our graph before I move on to the next one. Notice that I predicted that it was going to rise on the right, and I predicted that it was going to rise on the left, and I did that all before I put it into Desmos. I did that simply by looking at its leading term. All right, so what happens when my leading term is positive still and my highest coefficient is odd? Remember, we're still going to be looking at this leading term, and you have to make sure you're in standard form, which means we are in descending numerical order with our exponents. All right, so the right side of my graph is going to be uh, based off of my leading coefficient, this number right here, if it is positive. Okay, when my highest degree for my left side is odd, 1, 3, 5, 7, 9, 11, 13, we just can keep going, right? It's going to tell me something different. So here we go. Here is my example. I'm going to find my leading coefficient. There it is. Remember, you always want to check the biggest exponent and then count down from that number. 3, 2, 1, none. We're good. We're in standard form. All right, so in my leading term, I want to make sure that I have my leading coefficient. Notice it is positive 5. And then I'm going to circle my my highest degree to make sure that I know if it's odd or if it's even. I always go to the right side first. In this case, when my right side is positive, just like in the last one, it is going to rise. My right side rises, it's going to go upwards again. So the graph is going to look something like this on the right side. This is, of course, because my leading coefficient is positive, which means I don't have to go to the graph. And what this means is that as x is approaching positive infinity on the right side of my graph, my y values are also approaching positive infinity. As my graph is rising, both x and y are going towards positive infinity. All right, the left side, because it is, or sorry, my left side does the opposite of the right side. It does the opposite of the right side of my function. Why? Because the highest degree is odd. I want you to look at that. Opposite and odd start with the same letter. And so that's how the math is trying to help me to remember what happens. So when it's odd, it does the opposite. So instead of rising, this one is side is going to fall because that's the opposite of what it is doing. What's happening over here is that as x approaches negative infinity, because on the left side of my graph over here is always negative infinity, and that's why we always talk about negative infinity on the x. Y is also approaching negative infinity. What's going to happen in the middle of my graph depends on what my degree is. So that could be what my graph looks like. All right, let me slide down so that I can see the graph. Let's go ahead and put it in Desmos just to see, did we get this part correct? That's the only reason I'm showing you Desmos. Because the whole point of this lesson is for you to not use the calculator. There we go. And take a look at that. The graph is rising to the right and it's falling to the left, just like I predicted it would. So here's some points. Let's see what we can graph. I think I can graph -1, -6. Let me see. 1, 2, 3, 4, 5, 6. Yes, I can. And I, of course, can graph 0, -1. And then I think I can graph 1, 4. 1, 2, 3, 4. Yep, there we go. And it does something like this. Okay, something like that. I did the best I could. All right. So that includes when our leading coefficient is positive. What about when it's negative? All right. So once again, just remember you have to be in standard form, which means you have to be in descending numerical order for your exponents. And we're looking for this guy right here, our leading term. All right, in our leading term, the right side of my graph is going to be predicted by my leading coefficient. This time, it's going to be negative. The left side of my graph is going to be predicted by my highest degree. This time, we're going to talk about when it's even, 2, 4, 6, 8, 10, 12, 14, 16, so on and so on. All right, so take a look at your leading term down below in my example. Notice that the leading coefficient is -1, and the highest degree is 6. Now, I probably should have counted down just to make sure it was in standard form, but I was guessing from the other two that it was. 6, 5, 4, 3, 2, 1, none. So it is. It's okay. It didn't skip around. All right, remember you always have to do the right side of the graph first because the left depends on the right. When the leading coefficient is negative, the right side is going to fall. So it falls, which means it's going to go down. Kind of makes sense, right? We talked about it positive, it was rising, rising, rising. So of course, when it's negative, it has to fall. This is because my leading coefficient is negative. And I just want to remind you that that minus sign is for it being negative. That's why I'm writing it in here pretty small. This means that as x approaches positive infinity, remember, we're talking about the right side of the graph, right? So this is positive infinity on the right side of the graph. As x approaches positive infinity, y is going to approach negative infinity because it's falling. What about the left side? Well, the left side depends on the degree. Because my degree is even, my highest degree this time is even, it's going to do the same. So the left side does the same. And of course, we're talking, oops, maybe I should say as the right side. So my right side is falling. Guess what? So's my left. And I'm going to have some kind of twists and turns in here because that's what a polynomial does. What's happening over here is as x approaches negative infinity, take a look. Here's your x, and we're on the left side of the graph. This is negative infinity. Y is also going to negative infinity. Let's go ahead and look at Desmos to see if we can find the graph if we predicted the ends correctly. It's time to go home. All right, negative x to the 6th power plus x to the 3rd power. Get out of there. There we go. Minus x plus 2. All right, let's see. Look at that. We did. It is going up. It is going downward on both sides. It is falling on the left side and falling on the right side. Here are some points that I can plot. Negative 1, 1, 0, 2, and 1, 1. Okay, but I have to be careful. Take a look there. It's going to come up, go a little bit higher. It makes come kind of swoop. There we go. I did the best I could. All right, there's one last end behavior that we need to talk about. So we talked about positive and even, positive and odd, negative and even. The last one is going to be negative and odd. Just a very quick reminder, it has to be in standard form, which means your exponents need to be in descending order from largest to smallest, and you're going to look at your leading coefficient, which is the first one in standard form. Once again, the right side is going to be predicted by this leading coefficient, and this time we're still talking about it being negative. Your left side of your graph is going to be predicted by the highest degree, and this time we're going to talk about what does it look like when it is odd, 1, 3, 5, 7, 9, 11, 13, and so on. In my example below, let's check to make sure that we are in standard form. The largest exponent I see is 5, so I'm going to count backwards. 5, 4, 3, 2, 1, none. We're okay. All right, so this is my leading coefficient. And this is my leading term. Here is my leading coefficient. Notice it is -2. My highest degree is going to be my odd 5. The right side is going to go ahead and fall. It falls, which means it's going to go down. It's going to look something like this. And this is because my leading coefficient is negative. Once again, what this means is that as x is approaching positive infinity, and remember we're on the right side of the graph, so this is my x-axis and these are the positives, so this is positive infinity, right? 1, 2, 3, 4, and so on. Y is going to approach negative infinity because it's falling. My my highest exponent in this one is odd, so the left side is going to do the opposite. It does the opposite of the right side. And this is because my highest degree is odd. All right, so my right side is falling, my left side is then going to rise. My left side is then going to rise. And in between, it looks something like that. I don't know how many waves there are. What this means is as x is approaching negative infinity, think about this, we're on the left side of my graph. Here is my x-axis. These are my negative numbers. So this is negative infinity. As x is approaching negative infinity, y is approaching positive infinity because the graph is rising. All right, let's go ahead and take a look at this function, this example in Desmos to see if we predicted the end behavior correctly. Let me grab my pen so we can graph it. All right, negative 2x to the fifth plus x minus 4. We sure did. Look at that. It looks almost exactly like it, at least on the ends. Now I got too many minimums and maximums in there. I got too many hills in there, too many bumps, but that's okay. Let's go ahead and grab some points. -1, -3, 1, 2, 3, 0, -4, and 1, -5. And I'm going to take a look at what my graph looks like. Okay, so it's going to come down, and then it's going to do this, and then it's going to do that, and then it's going to do this. There we go.